The bottle in your hand has a blue label, a picture of a mountain, and the words 100% natural spring water. You've probably bought this exact brand hundreds of times. You buy it because you trust the consistency, you trust the source, and you trust that the liquid inside comes from a specific place. But if you analyze the supply chain logistics behind that bottle, you discover something surprising about how the FDA regulates the bottled water industry. The water you're drinking today might not come from the same location as the water you drank last month, or even last week. The brand stays the same. The label stays the same. But the geological origin shifts by miles across state lines without a single word changing on the packaging. This happens because of how Title 21 of the Code of Federal Regulations, Section 165.110, defines spring water, and the definition contains a provision most consumers never see. This creates something interesting that millions of consumers experience, but rarely understand. You take a sip of your regular brand, and it tastes flat, or heavy, or just slightly different than you remember. Most people dismiss this as their imagination. In reality, your palate detects a shift in the industrial sourcing network. You're tasting a change in the extraction point. To understand why this happens, we need to examine the rigid, yet surprisingly flexible, legal definitions that govern the bottled water industry. This isn't a story about deception. It's a story about how the Food and Drug Administration defines a natural resource for mass production. It's about the disconnect between the romantic idea of a spring and the engineering reality of a borehole. In previous episodes, we explored how purified water gets engineered for absolute sameness using reverse osmosis. Spring water operates on a completely different industrial logic. It doesn't get engineered, it gets managed, and the mechanism that allows companies to manage it at scale comes from a single clause of federal law that redefines what a spring actually means. The FDA defines spring water as water derived from an underground formation from which water flows naturally to the surface of the earth. On the surface, this aligns with what consumers picture: a bubbling brook in a pristine forest where water gets collected as it emerges. However, the modern beverage industry can't operate on the erratic flow rates of natural surface springs. If a factory needs to bottle 50,000 gallons an hour, it can't rely on gravity and nature's whim. To solve this volume constraint, the regulations include a critical provision. The law states that spring water doesn't actually need to be collected at the spring. It can be collected through a borehole tapping the underground formation feeding the spring. This is the industrial mechanism that changes everything. A borehole is a drilled shaft, an industrial well equipped with high-capacity pumps. The regulation allows companies to drill into the earth, sometimes miles away from the natural spring opening, and pump water directly out of the aquifer before it ever reaches the surface. This practice is perfectly legal, provided the company can demonstrate a hydraulic connection. They must prove, using hydrogeological methods, that the borehole draws from the same underground water table that feeds the visible spring. If that connection exists, the water pumped from the deep industrial well becomes legally identical to the water flowing from the surface spring. Think of it like a municipal water system versus a river. The natural spring is the river mouth where water flows out. The borehole is a pipe jammed directly into the reservoir that feeds the river. It allows the industry to bypass the slow, natural flow and extract water at the velocity required for modern logistics. This distinction between the natural spring and the underground formation is where the supply chain flexibility begins. An underground aquifer isn't a small pool. It's often a massive geological structure stretching for hundreds of square miles. As long as a company can prove the hydraulic connection, they can drill multiple boreholes at different locations along that formation and treat them all as the same source. This brings us to the logistical constraints that force these sources to change. Environmental variables become the enemy of industrial consistency. Aquifers like the Floridan system in Florida or sandstone formations in Pennsylvania rise and fall based on rainfall, snowmelt, and drought conditions. A borehole that was productive in the spring might see its flow rate drop by 30% in the late summer. When a primary extraction point slows down, a bottling plant can't simply stop the production line. The fixed costs of the factory, the blow molding machines, the labor, the electricity continue to pile up. To maintain throughput, companies often activate secondary boreholes. These might be located 5 miles away, 10 miles away, or at a different depth within the same aquifer. From a regulatory standpoint, this remains spring water from the same general formation. But from a geological standpoint, the water has changed. Water derives its taste from the minerals it dissolves as it travels through rock. Calcium, magnesium, potassium, and silica act as a flavor fingerprint. When a company shifts extraction from borehole A to borehole B, the water travels through a different section of rock. It might spend more time in contact with limestone, increasing the calcium load. It might travel through a layer of sandstone that filters it differently. The chemical composition, the total dissolved solids or TDS, shifts. This is your aha moment as a consumer. When you taste that your water suddenly feels different, you're not imagining it. You're detecting a change in the mineral profile caused by a logistical shift in the extraction network. The label hasn't changed because the regulatory category remains valid, but the physical product has been sourced from a different coordinate in the earth. This flexibility expands even further when we look at the structure of large-scale contract bottling. Many of the store brands you see, the generic spring waters sold at grocery chains, aren't bottled by the retailers themselves. They're produced by massive third-party bottling companies that operate dozens of plants across the country. A single contract bottler might manage 20 different spring sources across 10 different states. When you buy a bottle of store-brand spring water in Florida, it might come from a local aquifer. If you buy that same brand in Georgia, it comes from a completely different geological formation. Even within the same region, logistics dictate sourcing. If a specific spring source in Pennsylvania faces a permit restriction or a drought limitation, the bottler can shift production to a facility in New Jersey that sources from a different aquifer. The truck delivers the same branded bottles to the same supermarket shelf, but the water inside has been swapped for a geographically distinct liquid. This system is designed for supply chain resilience. It ensures that no matter what happens to the water table in one specific county, there's always product on the shelf. But it fundamentally breaks the consumer expectation of permanence. We tend to view spring water as a place, a static location on a map. The industry views spring water as a compliant category, a set of parameters that can be fulfilled by interchangeable sources. Beyond FDA minimums, the International Bottled Water Association sets additional voluntary standards that some bottlers follow, while NSF International provides third-party testing certification. But these quality frameworks don't address the geographic flexibility built into the spring water definition. This tension between category and geography is currently playing out in high-profile legal challenges. The most notable example involves Poland Spring, now owned by Primo Brands after Blue Triton acquired it from Nestlé in 2021. Since 2017, the brand has faced ongoing class action lawsuits alleging that their water doesn't meet the FDA definition of spring water because it's harvested from engineered sources rather than natural springs. The company maintains that their sources are fully compliant, citing valid hydraulic connections and geological data. The courts have allowed these cases to proceed not because they've proven fraud, but because the definition of spring water itself contains enough ambiguity to warrant factual investigation. How distinct must the connection be? How much engineering is allowed before a spring becomes a well? The dispute exists not because the rules were broken, but because the rules themselves were written to allow industrial extraction while preserving a natural label. These legal battles highlight the industrial reality. The water you drink results from engineering decisions. Even natural water gets mediated by pipes, pumps, and hydrogeological surveys. The water gets captured, not just collected. Climate pressure is accelerating this dynamic. As drought conditions become more frequent in the American West and Northeast, the stability of traditional surface springs degrades. We're seeing a shift where companies must drill deeper or move further afield to find viable extraction rates. In California, during periods of intense drought, bottling operations have had to navigate complex water rights and declining aquifer levels. When a historic source becomes stressed, the system adapts. It finds a new extraction point that meets the legal definition. The consumer, standing in the aisle, sees no difference in the packaging. The only signal that the system has adapted is the subtle shift in taste on their palate. This brings us to the question of transparency. The current labeling laws don't require companies to list the specific borehole or the precise GPS coordinates of the extraction. They're not required to notify consumers when they switch from a primary source to a backup source. As long as the water meets the definition of spring water and meets safety standards for contaminants, the label remains compliant. It's important to understand that this isn't a safety failure. The water from the backup borehole gets subjected to the same testing and filtration requirements as the primary source. It's not dirty or bad, it's simply different. It's a different geological vintage. But this difference matters because it reveals the hierarchy of the system. The system prioritizes volume and availability over consistency of character. In the world of wine, a change in the soil or the weather gets noted on the bottle. The vintage changes. In the bottled water industry, the goal is to mask those variations under a uniform brand identity. When you drink purified water, like Dasani or Aquafina, you're drinking a product of chemistry. We know from our previous analysis that this water gets stripped and remineralized to be identical every time. It's the control group. When you drink spring water, you're drinking a product of geology. And geology is messy. It varies. It changes over time and distance. By bottling it at an industrial scale, companies are attempting to force a variable natural resource into a standardized commercial box. The leak in this system is the taste consistency. The slight metallic tang, the sudden perception of hardness, or the feeling that the water is flat, these aren't defects in the traditional sense. They're the fingerprints of the specific rock formation that yielded that specific batch. They're evidence that the water in your hand connects to a specific physical location, even if that location has shifted since your last purchase. This also explains why some consumers find themselves suddenly disliking a brand they've been loyal to for years. It's common to hear people say they changed the water. In many cases, the company didn't change the formula because there is no formula. They simply moved the pump. Or the aquifer itself changed due to heavy rains altering the groundwater chemistry. The consumer reacts to a geological event, mediated through a plastic bottle. So how should an observer of industrial systems navigate this? First, abandon the assumption that a brand name equals a specific water source. Unless you're buying from a small boutique bottler that owns a single spring, you're likely buying from a network of sources that fluctuate based on logistics. Second, read the fine print on the bottle, but understand its limitations. Some labels will list sources, A, B, C, or D, followed by a series of codes. This is the company legally covering its bases, admitting upfront that the water could come from any one of several locations depending on the production run. Third, recognize that taste is data. If you're sensitive to mineral profiles, you're essentially performing a quality control check on the extraction point. If the water tastes different, the system is moved. The bottled water industry is a marvel of logistics, capable of moving millions of gallons of heavy liquid across the country while maintaining safety and low cost. But it creates an illusion of permanence that physics and geology can't always support. The label tells you the regulatory category. The taste tells you the geology. The next time you crack the seal on a bottle of spring water, remember that you're not just drinking a beverage. You're sampling a specific cross-section of an underground aquifer at a specific moment in time. The label tells you it's spring water, which is a regulatory category. The taste tells you where it actually came from. The system works because most people stop at the label. But as we've seen, the label is just the paperwork. The reality lives in the rocks, the pumps, and the pipes that bring the water to the surface. When the system meets the constraints of the real world, droughts, distance, and demand, the water changes. The fact that you can taste it proves that the system operates exactly as the regulations allow it to.